All right, here's your typical hobby type machines. I just took a few screenshots off a search on the internet of this type of machine where you could conceivably do some kind of milling on the turning part in the lathe. But these all have the disadvantage of not being able to move in the y-axis. Now this one, I think it's Swiss Mac, can do that all like a real mill turn, but these others just don't have that ability. And also, these Deckel and Schwablin type of machines are kind of interesting the way they work, but still, they all don't have the ability to actually do milling and turning and five-axis positioning type of work.
All right, here's my idea of a small, like DIY mill turn type of machine. Now, the normal way they make these machines, like my Mazak's made, they have this big long slideway, and the X and Y and the B axis and everything rides on it. But that's not too practical to actually build, for a DIY project. So I thought this might be better, where the lathe part, the turning part, actually moves on this slideway back and forth. Let me see if I can actually move the. So if we move the saddle, can can move back and forth like this, okay, and the the whole bed of the lathe can move in and out like this. So that's the way. If we look at this probably from a different angle, that's the way you can actually go in and out with the x-axis and everything. We get back to the beginning here, and this I've just got this blocked in very crudely, just so you can kind of get an idea of what I'm thinking. This would be the here would be the milling spindle, if you will, or even where you'd mount turning tools and milling tools. And of course, all of this has to have motors laid out. Like the motor would probably be up above this milling spindle, and over here somewhere where the turning spindle, and it would be belt driven on the back here. Now I'd have to figure out some way to rotate the C axis, and also to rotate the B axis. The B axis here, like if we just grab onto this, doesn't really have to rotate, but more than back and forth like this. So that's pretty simple, and that can actually be done with simple mechanism because it doesn't have to move, but maybe 180 degrees or so, or a little more. But the C-axis is a little bit more complex thing. If you remember, I was toying with the idea of a cam roller type drive. I don't know that if I can make that work or not. Maybe with a high resolution servo motor belt driven to the spindle itself would be good enough resolution for C-axis indexing. Have to experiment with that, but anyway, this is kind of the idea. So if in order to turn lengthwise or mill lengthwise, you can go this way, and in order to come in and out, so to turn different diameters or mill smaller sizes or whatever, you go that way, and then the y-axis here would be going up and down this way for the y-axis. So that's the way it would work, and then the v-axis, I should say, will rotate on this rotary axis down here. So that's sort of my idea on how this might work. It'd be fairly simple to build, and I try to keep the overhangs as short as possible. And I think this is the best way to do it. To actually put, of course, this is just blocked out, but there'd be linear guideways along this level here, and this would be the saddle piece, kind of like the saddle on a Bridgeport mill, between knee and the table, and there would be a linear guides on the bottom here that would support this. And this model is drawn about, this is about 48 inches long, and from the center line of the spindle down to the floor down here would be also about 48 inches. This, what I've got here, I just downloaded somebody's model of a Kitagawa chuck here, and this is a 6-inch chuck on here. Either have a chuck or a collet attachment or something like that. And the tail center can be moved back and forth to grip on shorter parts, longer parts, or even taken off completely here. And there might be even a possibility of putting a steady rest on here and stuff like that. That might be possible. I don't know. Most of the time, you're going to be probably not doing parts between centers on this kind of a machine. You're going to be doing almost like a 5-axis milling work, if you will. And so the y-axis can be rotated. Let me grab it here. Can be rotated all the way so that you can be parallel to the z-axis. This, of course, you'd have to have the lathe bed probably over this way if you're going to leave the tailstock on, but there's plenty of room for that. And you could be over here working on the end of the part, or at any angle you so chose, you know, if you want to be over here. Now, I made this little thing here. If you were to make this machine kind of like in a manual type of thing, I haven't got that drawn correct in the CAD software to. But if you're going to do it as a manual machine, I thought it might be nice to be able to move this as if it was like a quill on a Bridgeport mill, and you could have some lever operated device and manually drill holes at different angles and parts. You could make this as a manual machine even if you wanted to. For some reason I haven't got this thing constrained right, but you could move it in and out. You could make a lever operated thing, I guess, or some sort. You can move it in and out to drill holes. Now, the reason I even like this configuration of a machine is that after using various types of machines in my machining job, I found that this machine is the most useful configuration of any machine that I've ever run, because you can do more or less everything you need to do. You could even mill T-slots or something in the face of this, and you could even use this as a milling machine if you just took off this tailstock and you clamp parts on here, kind of like a horizontal mill on the side of the tombstone. You know, if you brought this thing forward, you could even machine, and you could even tip the B-axis at angles and do almost like, not really 5-axis, because you need the C-axis rotational direction, but you could do various things. You could mount a work holding fixture on there even and use it that way too. But for the most part, most of the parts you make when you machine start out as a lathe part, and then they go over to the mill and they get milling done, or they get holes drilled in them, or various things like that. And this type of configuration of a machine covers almost everything you need to do in the machine shop. Like, I would say 90% of everything. There's only the parts that are straight milling jobs that are large that it wouldn't really cover probably as well. But for your general type of what I would say a hobbyist type of machine work that most people do, a machine like this could do everything. And you wouldn't really need but one machine to do everything if you had a machine like this. So I think it could be a good alternative to having a separate milling machine and then a lathe and all of the fixturing that goes with having those two pieces of equipment in order to do what this machine could do all in one machine like this. So anyway, that's kind of my thought process here now. If I could just maybe flesh out this design in more detail and everything, and possibly even build one of these things. I don't know. Let's see.
Anyway, that's my idea on the machine. Here's some shots that I did on a part a long time ago that I never, before I made YouTube videos, I never really posted any of this on the internet. And this is the type of work you can actually do with these type of machines. You can turn the diameters and you can do the milling and everything all at the same time. There's that hole. There's 4 holes that had to be drilled, and then this all had to be milled and turned out, and all the details in the bottom of that with that face groove in the bottom of the bore and everything. So these parts I did before I was making YouTube videos. So anyway, that's just my ideas on a possible machine that I could build if I can ever get the time to do it. So thanks for watching.